Okay, so today's first lesson is going to be looking at multiplying polynomials with monomials. So last day we looked at monomials and monomials, so one term and one term. So today we're going to look at one term being multiplied by more than one term. And how do we accomplish that? Okay, and before we do that, I'm going to do a side example. All right, if I gave you the question, stop expanding on me, 3 times 2 plus 4 in brackets, and asked you what does this equal, what would you say it equals? Yes, Theo?
18.
Yes, and how did you do that?
2 plus 4 is 6, 3 times 6 is 11.
So 3 times the stuff in the bracket, 3 times 6 is 18, and I completely agree. And that's what you've learned. You do the stuff in the brackets first, and you combine it, and you multiply by the stuff that's outside. Now what happens is, what if you can't add, can't simplify the stuff inside the brackets? How do we clean things up? How do we simplify it? And what we do is use something called the distribution property, which means is like, so this kind of circumvents sort of the bedmass a little bit, but still stays within it. What we can do is the exact same question is, take this 3 and you multiply it to everything inside the brackets. So we can go, instead of 3 times 6, we can go 3 times the first term plus 3 times the second term. Okay? So that would be 3 times 2 would be 6, plus 3 times 4 would be 12. And if we added those together, 6 plus 12 still gives us 18. And we wouldn't do that for this kind of question because it doesn't make sense. It's a lot of work. But when we start dealing with polynomials, we can't combine the stuff in the brackets, and we have to use this math property, okay, which is called the distributive property. So let's look at that. Okay, so to multiply, come on, polynomials by monomials, we use the distributive property. Here's a distributive property which allows us to expand the algebra expression, right? Distribute means it's just distributive means distribute the 3 through the bracket, distribute it, right? So how do we do this? By multiplying the monomial by each term in the polynomial. Okay, so let's have a look at this. So this is just a generic statement for math, but let's put it to work. All right, so we have a monomial here, and we want to multiply it to this polynomial. So we can't combine what's inside the brackets. So what we do is we take this 2x, we multiply it to the first term, and so I'll write it out to begin with. You don't, at the end, we're not going to have to do this many steps, okay? Then you multiply it to the second term, which would be plus 2x times 3. Remember those dots means times, right? But I don't want to use the x because that adds a lot of x's. So maybe actually I should change colors. Make it a little bit easier to see here. Come on, Reese. 2x times 3. Okay? So now we clean it up. Well, you clean up the first one, 2x times x. Remember, when we're multiplying variables, we add the exponents. That becomes 2x squared. That's what that equals. And 2x times 3, we multiply the coefficients. Becomes 6x. Doable? Right? So now it doesn't matter what side the monomial is in. It could be on the front, it could be in the back. The same rule. That is annoying, whatever that sound is. Music, flute or something?
Yeah.
Yeah. Recorder. I remember when I was in grade 2, and one of the tests we had to do is that they just played a recording of all these instruments, and you had to identify the instruments. I was horrible. The only thing I could pick out was the piano and the guitar. Right. So, if you have the order reversed, it doesn't matter. The key is we could go everything in the left bracket has to multiply everything in the right bracket. Just think of it that way. We could go like this. 2 times c is 2c, right? And we go c times c is plus c squared, right? Or if we wanted to, and if you prefer, it's sometimes easier to go from the one term to the multiple terms. You could go in the other way. You could have done this. You could have said 2 times c is 2c, and you could have done c times c, c squared, right? It doesn't matter the order. Because think of it as multiplication. 3 times 2 is equal to 6, but 2 times 3 is also equal to 6. So the order doesn't matter in that sense, right? Whatever method you find easier. Okay, so we've got 4 questions there. Which 2 do you want me to do?
All four.
No, 2 of the 4. Brooklyn, which ones do you want me to do?
E.
Okay.
F.
E and F. Okay. Let's start off with E. Okay. So maybe I will write out the steps, but if you're comfortable, you can do it all at once. Okay? The stuff outside multiplies the first term. So we have negative 4 over 3x, I'll put the x on the top, that's the same thing, times 6x. And I'll make that a fraction because we're dealing with a fraction. So 6x over 1. Okay? Then the same thing multiplying the second term. So we have we can go add, you can add a little plus sign, negative 4x over 3 times negative 12 over 1. And we clean that up. Okay? First one, we multiply the tops together. 4 times 6 is negative 24. Right? And then we have x times x, which is x squared. All over 3. We multiply the bottoms together. Right? Okay. Now, second one, multiply the tops together. Negative 4 times negative 12 is positive 48. So plus 48. And there's only one x, so that leaves as an x. And we divide that by the denominator. 3 times 1 is 3. Now we look at this and we say, can we simplify this further? Well, 3 can go into 24 8 times. So the first one could be now, running out of space here, can be rewritten as negative 8x squared. And you go 48 divided by 3, that would definitely divisible by 3. Does anybody know it? If you don't know it, you pull out your calculator. Right? You go 48 divided by 3, 16. Right? And you go plus 16x. Right? Remember to include the sign. So you wouldn't write down 8x squared, then have no sign, then 16x. It makes it look like it's one whole thing. So you need to have the plus sign. Or if it's a minus sign, if it's negative, the negative sign. Right? Now, if you wanted you could have applied some of your fraction simplifying rules from before. You could have looked at this and said, hey, there's a 3 here and a 6 here, right? You could go, well, 3 goes into 3 once, it goes into 6 twice. You could go -4 times 2 gives us the -8, right? And you could have gone this 3 and this 12. Well, 3 goes into self once and goes into the 12 4 times, and you could have done -4 times -4, which is the 16, right? So just something to connect to from the previous chapter. But if you find it easier, just multiply the tops together, clean it up afterwards. Okay. The next one is just the same as what we did before, right? Except for we just have decimal numbers, right? Not everything in life is whole numbers, very few things are, right? So the rules are, you take the number up front, it multiplies everything in the following bracket. So we go 4.2 times 4.2n times 2n. What does that equal? Well, 4.2 times 2, yes?
8.4.
8.4. And what's the variable look like?
It's N2.
Yeah, n2, n squared, right? Then we do the second term. We go, switch to red here. We have plus 4.2 n times -7. And so you go, oh, I can't do that in my head. And I go 4.2 times -7 is -29.4. So you go -29.4 n. And if you get good at it, you don't have to show the middle step. You can just go straight to the third step, but depends on where you are in the comfort level. So give C and D a try. So looking around, I'm glad to see lots of people feel comfortable to skip the middle step. Some people are writing the middle step and it's causing some errors. So if you do the middle step, remember to include brackets, because that'll help reinforce that it's a multiplication and doesn't something that accidentally look like an adding and subtracting. Okay, does somebody want to share C with me? Scarlett.
-9 and x squared.
Okay, so you did this one, that'd be 3 times 3 was -9, and x times x, x squared. Great.
And the next one is 18x.
18x. -3 times -6, positive 18, so plus 18x. So remember to include that plus sign, so it doesn't look like -9x, then you see, all of a sudden you see the 18x there. Yes, Kim? Yeah. Okay. So next one. Does anyone want to try that one? Again, Scarlett? Okay.
Yeah, this one is first part 4x times 2x.
Yeah.
It's 8x squared.
Yeah.
And then the next one is 4x times -1, which is -4x.
-4x. I saw quite a few 3x's there. All right. Remember, you're multiplying. So 4x. If you're stuck, it went 4. Maybe I should use the right colors here. It went 4x in brackets times 2x. Then we did, in red, I guess, we did plus 4x times -1, right? So you got the 8x squared, and you got the -4x. Okay. Now there is another strategy to multiply these kind of terms together, especially when you get into, like, this is just a monomial with a binomial, but what if you had like a trinomial or something with 5 terms or 6 terms? Sometimes you can get lost in it, and there's something called an area model. So the area model looks like this. Suppose we had a question that went 4x times 3x plus 5. What you do is you put one thing that you're multiplying here, then you go, the other thing you're multiplying goes along the top. Okay? Then you make a little grid where we see the plus signs. Okay? And what we do is we multiply the term here with everything here and whatever makes up this box. So this box times this thing. So 4x times 3x would be 12x squared. Then you go, okay, what's the coordinates here? We have 4x and a 5. That'd be 4x times 5. So that'd be 20x. And what does this multiplication represent? Is 12x squared plus 20x. Okay? So it seems like a lot of work for something like this, but when you have 3 or 4 terms, this model can help do that. Right? Just help collect your terms. And off of this model, what this is actually a simplified algebra tile. So I'm going to show you how to do an algebra tile using the exact same thing, because you're going to come across those questions. So to do an algebra tile on this is one of the multiplications, all the multiplications go along the sides. And you draw up the multiplication. So a 4x looks like this, four of the rectangles. That's what 4x looks like. So you draw out one of them, and we shade it in since it's positive. Okay. And what does 3x plus 5 look like? Well, we have 3 rectangles. Shaded in, and 5 small squares. 1, 2, 3, 4, 5. And those are all shaded in. Okay. So what you're multiplying goes on the outside. What it equals is all the shapes inside. And how do you determine the shapes inside? Is you go the length of this shape will be the length of the shape made by this one and this one. The width of this shape tells us how wide this is going to be. Right? Then you know what the shapes are. You have a large square, you have a rectangle, and a small square. So this finished off is going to look like this. So it's a big square. Right? And going across, you know that following the same thing here, this is going to be a big square, and this is going to be a big square. Is that okay? Does that make sense? That's how you determine the shapes. And going down this way, going down once again, comparing this shape here, draw here, right here, this is going to be green, this one's going to be blue in this length, and we finish off this shape. This is what the shape is going to be. So going down, this is going to be like this, this is going to be like this. So that tells you what the shapes are. Okay? So let's fill all of these in. Give you a second to create all those. Okay. So next, once you guys got that, is because we need to do every combination. Yes, dear? No, understand? Okay. So we have this small square. Well, that's only this wide, right? And the blue line is this wide. So we combine that together. It makes a rectangle, right? And that's going to be this case for all of these. It's going to be a rectangle here, and a rectangle here. And the same thing goes for the next one. Well, that's this dimension. Well, that's a blue here, so that's going to be this long. Then we fill off the sides. Well, that has to be a rectangle. And we go, okay, all of these are rectangles. So every combination is going to be a rectangle. So then we got to do all these as rectangles. So this method is a nice pictorial method. Unfortunately, it just takes a long time. You're welcome to use this method for your multiplication. It's a good starting off point. But eventually I'd like you to be able to go to the algebra method. So right now, hopefully you have a whole bunch of white shapes there. Right? But tiles can be black and white. So the way you determine what color the inside tile should be is by knowing our multiplication. If we multiply a positive with a positive, we know that this should be a positive shape. This positive times positive is there, right? Now, if it was a positive times a negative, then it would be in a negative shape. We would have left it white, right? But all these are black times black, positive times positive. These are actually all shaded in. And there'll be a few questions, these kind of questions on your homework, just because these kind of questions do show up on various kind of tests. So all these should actually be shaded in. All shaded in. All shaded in. All right. Okay. So then you go, what does this equal? You simply count up the boxes. We've got 1, 2, 3, 4, 8, 12 of the squares. So we have equals 12x squared, and we have 20 rectangles. So this is 20x. Okay. Another way to get to the exact same answer.